Good morning, everyone. How's everybody doing this morning? I hope you're all doing well. Testing, testing. 1, 2, 3. Testing, testing. Am I feeling better? I'm beginning to feel better. For those of you who may not be aware, I was feeling pretty, coldy on Friday, and I looked a miserable sight, and I'm beginning to, actually, I've been better for a couple of days now. How's Le Bebe? He's doing well. He's, turned, actually, 7 months old yesterday. He's, it's kind of interesting. There are some things that he's, pretty highly, advanced in relative to where he should be at his age, and one of those is walking and, getting up on his 2 feet. He can... his favorite thing this week is being held by the hands and just, kind of walking from room to room. But yeah. Yeah, so, So the midterm, then. Well, he hasn't quite learned coding yet. Has it really been 28 weeks? My goodness. But, actually, Mr. Freshly Squeezed, if I may correct you on that, I learned this out. They don't really count by weeks after the second month, because after a certain amount of time, the weeks become desynchronized from the months, and it's the months they go by. So once they hit 2 months, officially in medical records and stuff, they count by months rather than weeks. Which is something I figured out when I was in that position, because you find these things out when you're a father, But, anywho, so I wanted to talk a little bit about the test. In particular, I wanted to talk about the bonus question. So I'd like to apologize for it. It dealt with subject matter which was upsetting to some of the people in the class, and for good reason. And I don't, I don't really, there's no excuse I can give for it, Over the course of the semester, I've been kind of, my thoughts have been turning to sort of darker subjects as things have been going on, which, might be an indication that I should go talk to a counselor. But, which I'm probably going to be doing, although I think maybe just interacting less with the news feed is probably a good remedy for it as well. But at any rate, the subject matter of that bonus question didn't have to be, dealing with the dark themes that it did. It could have worked just as easily if it had been bunny rabbits or jelly beans. It contributed nothing to the mathematical question at hand, right? So, yeah, that's, yeah, I'd like to say that it was not my intention with that question to make light of situations like that. I wasn't, like, going for, like, sort of tongue-in-cheek humor with that. It was just sort of, it was what it was. The question was also based on a, one of these, like, coding competition style problems that I encountered over the summer. You know, so now you know where I get some of the questions for the tests, at least, is, you know, these sorts of, you know, some of the best programming questions are being produced for these coding competitions. So it's useful to take a look at what they're doing. I didn't act like, in case you're worried that, like, I gave you a full-blown coding competition question. No, the version of that question that I saw was, like, a lot more complicated, for reasons that have to do with arbitrary knowledge about bitwise operators. But let's just say I'm very sorry. I won't do it again. And for those in the class who had to suffer through the psychological anguish or psychic interference from having such a question presented to them, I can only offer my most sincere and humble apologies for it. I'll never do it again, and you can believe me when I say that. So, I hope that I hope the class can forgive me for it, because, you know, I should have caught it, and I didn't. But, you know, there's any number of excuses I could make, but fundamentally it's my responsibility to make sure that the materials that are being presented to the students are wholesome, shall we say. But, yeah, and I had the chat turned off through this so that I could speak my piece without, you know, that sort of mental interruption. But yeah, all right, I'm going to see what people are saying about it now. No, I'm talking about the bonus question. The question entitled Prisoner's Dilemma. So I guess we could talk a little bit about the test itself. There are yeah, like, yeah. Oh my goodness. So a lot of people took a long time to do the test, it seems. So yeah, that was Sarth's question, actually, the Squid Game question. I did the Van Nyck sequence. You know, I arrogantly named the sequence after myself, as many programmers do, and then I also wrote the fifth question, which was the Josephus problem. It was an adaptation of the Josephus problem, which is actually, like, in a mathematical context, you may have heard of that problem as well. It's quite a famous one, from the math culture. It doesn't enter too much into the programming culture. That's why I get away with it. Sometimes I also derive idea questions from like math file and computer file videos on YouTube. But yeah, so I did that one and the bonus question. Those were the ones I wrote. But oh, so to understand the Van Nyck sequence question, it was just like in order to know what the particular value is, you basically had to trace back through the sequence using recursion until you hit something that was divisible by 5. In that case, that would like crunch the recursion back up. It was kind of like like how Fibonacci has to look back to see what previous Fibonacci values were. It kind of like it had to do that as well, but only until it hit the most recent division thing that was divisible by 5. So, so generally speaking, it seems a lot of people took a lot of time to do it. So this is sort of the way that things have to work here. When I set a test, it's important that not everybody gets 100%, which means that, it has, like, because it's a take-home test, there has to be a higher level of difficulty than if I were to put out a paper test, right? And, it's a known fact about these tests that people tend to take longer with them if, basically you can compensate for a certain amount of lack of understanding of the material or facility with the material by spending longer on the test, and that can get extreme in some circumstances. Yeah. It's unfortunately just sort of the way that these tests go. But about when can we expect the marks back? Definitely by the end of Thursday. We're just... we have some things that we need to validate before we, we want to be absolutely sure that the test, we don't want to have to fix the test cases afterwards, and it can be a little bit tricky. It can be a little bit tricky to get a test often the test questions will have a higher rate of the test cases being problematic, but just because the questions are new. Like any particular question on an assignment has been worked over at least 3 times, right? Whereas every question on a test is new that year, or new for that test. So, yeah. Can you talk about solutions now with friends? Well, yeah, I mean, everybody has at this point submitted the test, so you're free to talk about the test. I kind of expect people to talk about the test immediately after getting out of the room, but since you're not in rooms for testing now, it's, it is what it is. Well, let's put it this way. If I had been doing that test, it would have probably taken me about a half an hour. And, the general rule is that, the rules that profs usually use for how to time a test is it's reasonable to expect people to write a test in 4 times the amount of time it takes the professor to write the test. But, yeah. Yeah, so that's kind of... I'm still using that type of metric with it, but... Yeah, it's, this class isn't an easy one. I'll give you that. But, I'll put it to you this way. If you want to be a computer scientist, the content of this class is, you will pity yourself for thinking that this was a hard class by the end of your degree. Right? Things get much, much, much more complicated and difficult than this class by the end of things. So the reason that people pay people to write programming code is because it's a skill that not everybody has, and it takes time to develop the skill, and it's difficult work, right? So if you want to be a person whose degree is in difficult work, you need to be able to do the difficult work. But, you know. Yeah, lunch breaks don't count. Lunch breaks don't count. But, so, yeah. Anyway, we should, oh my goodness, it's already 9:46. I should probably get on with the, we shouldn't fall any further behind in the lectures than we already are. But, yeah, I mean, you're not allowed to talk to people about the test while the test is going on, but as soon as the test is over, although, if you wouldn't mind, in future, holding off until, like, roughly speaking, 9 o'clock at night, the day the test closes, because we do have some people with accommodations who, you know, who get an extended test writing time. So, you know, even though it's closed for you, there are some people who are still writing. So if you would please, like, leave off talking about it on the Discord and that sort of thing until, you know, yeah. Anyway, so you want a nice balance of feeling like you're learning and not just struggling. Yeah, that's what what's it called? Piaget, yeah, Jean Piaget, the French developmental psychologist. That's what he referred to as the zone of proximal development. You need to have enough foundation in what you're learning to not be just completely frustrated by it, but at the same time, it does need to push the boundary of your current set of knowledge. Solution/review would be nice. Yeah, I think we could probably arrange that. I'll talk to the TAs. I'll talk to the TAs about that. See if we can't put something together for you guys. Hey. Yeah. So let's continue to talk about computers and junk. All right. So, white box techniques. So remember, last time we were talking about the differences between black box and white box testing design. Black box, roughly speaking, is what we've been using so far for everything. You're focused on producing what are called unit tests, or just, you know, tests. You're designing sets of inputs for which you know what the expected set of outputs should be. How you arrive at those, you can use various ways to arrive at that, but one thing that you should not be doing is you should not be using the algorithm you're trying to test to generate the test case solutions for the testing that you're trying to do. Because, you know, any errors that are in there will just end up in your test cases. But, so, I always say that black box versus white box is kind of a misnomer. It really should be opaque box versus transparent box, with white box being, like, it is supposed to convey the concept of transparency, whereas black box is supposed to convey the concept of opaqueness. But we had talked about black box testing to a fairly high extent, so we were going to talk briefly about white box testing. Generally speaking, black box testing is more useful because you can get a computer to do it for you, but white box testing can be more thorough and more likely to pick up errors that are difficult to find because it relies more on human experience. So, white box techniques are called white box techniques because you can know the program's source code while you're designing the tests for it. This can, one popular way of doing white box testing is code review, where somebody else, like possibly even 2 or more developers, visually inspect the code, typically several times. These would typically be senior or advanced, you know, senior developers on the team, right? So the sorts of things they look for is checking for best practices, looking for potential inefficiencies, and looking for common vulnerabilities. So you, as a junior programmer, you would kind of be put in a position here under this type of code review. It's like, well, why did you do it like this? This is the way that it's been done for 30 years. And it's like, but I'm a new programmer, and I have my vision for the universe, and I have to be creative. I have to be given creative freedom. And then the senior programmer laughs at you and says, creative freedom? If you want to be a creative, if you want creative freedom, go write novels for a living. Generally speaking, the types of environments you'd find code review in is, you would find them in places where the software that you have to review isn't that long, right? Like, if you're, like, code review over, like, 200,000 lines of code, which is, like, some programs easily reach 200,000 lines of code, especially if it's written in a non-compact language. Like, code, white box testing becomes more expensive the, like, more lines of code there are in the program. So, generally speaking, it would be performed primarily over, like, individual modules or functions, not, like, completely, not the complete program, right? And generally this is done when you are interested in very high reliability software, right? So, like, and this kind of gets us into another idea, which is, like, the idea that there are different classes of software based on how reliable they have to be, right? Like, software runs everything these days. And, you know, there's all kinds of software where you wouldn't expect software to be. And some of that software has human life hanging in the very balance. A very traditional example of software that messed up, that actually killed people, is, I believe, during the 80s. It's less common these days, but back in the day it was very, very common for cancer treatments to occur using radiation, like focused X-ray radiation or higher energy radiation, gamma ray radiation, that sort of thing. Basically, the way it works is, like, you can direct these high energy beams in such a way that, like, the burn occurs exactly where the tumor itself is, in theory. So they had a machine to do this called the Therac 25, I think. But essentially, one person wrote the code for this thing, and there were bugs in it, and those bugs killed people, unfortunately. And part of the reason that those bugs killed people is because this particular programmer, I believe, was so arrogant as to assume that it was outside of his capability to write a program that had a bug in it. It kind of echoes the story. There's a story that's told in the engineering faculty. You guys may not have heard this, but you know the engineering rings, right? They've got the big one outside of JHE. I don't know if you guys have ever heard the story, but this is the story of that, right? In Quebec, they wanted a bridge. I don't know if this was in Quebec City or in Montreal, but they wanted a bridge over the St. Lawrence, right? Yeah. Some engineer from the States came up, I believe from the States, and was so arrogant as to assume that it was an affront to his, you know, to his dignity as an engineer to have anybody check his math. I'm telling you what the engineering ring is. So what happened was this bridge collapsed during construction because this guy had not calculated out the correct, like, the bridge, the span was too great for the members that made up the bridge, and the arrogance of this engineer killed, I think, on the order of 100 people. And I think I could be wrong about this, but I think that a lot of them were indigenous as well, because it was common. This happened like in the late 19th century, I believe. And it was common at that time, I believe, for indigenous people to have work in sort of heavy construction. So, you know, a lot of people died, and a lot of people didn't have to die, right? So, this is, I don't know, if you look up the date, I think it was in the like 1880s or 90s, but I could be wrong about that. But essentially, what they did is they took the steel that this bridge had been made of, and they started making these out of them, right? So this is a very important symbol to people in the engineering profession. You get your iron ring when you graduate from an undergraduate engineering program in Ontario. It's sort of associated with the PEO. 1907. Pardon me, it was 20th century. Very early 20th century. I was only off by 20 years. But the rings that we wear on our fingers symbolize to us that if we mess up, we can kill people. So that's why we always wear these things. Yeah, I did mechatronics when I did mechatronics when I was an undergraduate. I actually did my bachelor's degree at McMaster. Yeah. So that's what the ring means. It means don't be so arrogant as to assume that you do things correctly all the time. You know, don't be so arrogant as to assume that your math doesn't need to be checked, because people can die. People can and do die. So, yeah, that's true, actually, what Tanya says. Computer science isn't, like, I'm teaching you basically because the CS department is run by the software engineering department. So, yeah, no, so unfortunately, people in the CS program do not get engineering rings because you're not an accredited engineering program. But yeah, so anyway, so that's the story about the rings. And that's why it's important to to not be so arrogant as to assume that nobody can ever give you any criticism. Right? Yeah. So, yeah. Actually, so there is a path to entry, though. If you're doing similar work to an engineer, like if you're working essentially alongside engineers, I believe industry experience worth a full decade, then you can apply, I believe, to become an engineer, like a professional engineer in Ontario, without having done an undergraduate education, like without having done an engineering degree. I believe this to be the case. They may have changed the rules, but yeah. Yeah, the PEO. Yeah, so obviously, like, they ran out of the original steel from the bridge quite some time ago, so you know, all of the recent ones aren't made from the original bridge. But yeah, it's stainless steel. Anyway, so I should continue on. So in addition to people looking at your work, you can also get tools, like automated software tools that will analyze your work for common vulnerabilities. My sort of go-to example of this is a program called CPP Check, which we're going to do in 1XC3 next semester if you take it with me. That analyzes C code and C++ code for a suite of common problems and gives you a report so that you can fix them. Because it has to know, like, it has to analyze the structure of the program in order to be able to do that. That is white box testing, although it is reasonably automated. So the thing about, like, manual review is that it takes time and money, right? So ordinarily it's reserved for only those applications where, you know, success is absolutely critical. Yeah. So when we do white box testing, we also want to know whether our test cases are covering our code. Again, yeah, I don't know. Maybe CS people do get the ring these days. I don't know, to be honest with you. Engineering, but no, it can't be, because, like, in order to graduate from an accredited engineering program, you have to be taking accredited engineering courses. And believe me, I've taught engineering courses at you know, in the past, and I'm teaching one right now. And, like, the process is, like, it's a lot of paperwork to get a course accredited, and this course is not accredited with the PEO, and none of the CS courses are accredited to my knowledge. But anyway, so code coverage fundamentally asks the question, you know, are all of the statements in our program being exercised by our test cases? Again, when we take 1XC3 together, hopefully next semester, there's a whole lab on how to use a code coverage analysis tool called gcov that analyzes specifically C and, you know, specifically C and, you know, tells you whether every test, everything is being exercised. Yeah, the problem, if I may say, the problem with going on eBay and purchasing a ring like this is that you will be, like, you are occasionally asked, if you wear such a ring, like, what program, yeah, like, it's like, you can't really purchase membership into the cult of engineering. Because people will ask you questions, and then you will not be able to answer the questions, and then you will be exposed for the fraud that you are. So, yeah. But, so, anyway. Static analysis is, like the code analysis tools, all of the code analysis tools that I've been talking about, well, actually, no. Some tools require you to actually run the program, some don't. The ones that don't are called static analysis programs. Static analysis tools allow you to run automated tools to find flaws in programs. For example, do I try to use a variable after it's been freed from memory? Is it possible for a counter to go past the end of an array? This is less relevant for Python than it is for languages like C, where you can really shoot yourself in the foot. But I can see I've I can see I've started a fight in the chat. Jeez. Oh my gosh, I'm sorry guys. I have to plow through a few slides, so I'm just gonna mute you guys for a moment so I can get through like more than 2 slides this lecture. Okay. So, debugging. Once your testing has shown that your program doesn't behave as intended, you have to identify the bug and then fix it, or claim it's a feature. To find the bug, we need a couple of things. Number one, we need a test case that reliably fails. So if it only fails once, that's not usually enough information to be able to find the bug. You'll notice that, like, on bug reporting websites where, like for example, if you're playing Dwarf Fortress and you report a bug to the guys, to like the guy and a half who developed Dwarf Fortress, if you submit a bug to them and they're like, cannot reproduce, that means that your test case that you tried to tell them is not something they could reproduce, which means they don't know that the bug exists, right? Because they need a test case that can fail reliably. Because you kind of have to, like, change one thing, run it again, change another thing, run it again. The second thing you need to do is you need to try to understand the internal state of the algorithm. Dwarf Fortress is written in C++, by the way. In order to actually find a bug, you need to understand what's going on with the internal state. And, you know, there are there are three main ways of doing that. Most sort of basic and reliable is print statements. Next level up would be something like a debugger, which we're going to talk about. And the third level up from that would be something like Python tutor, which is, in my opinion, like kind of halfway between a debugger and a profiler, but you know. If Python tutor just told you like what the number of execution counts for each line of code was, then that would be a profiler. Anyway, to understand the internal state of the program, use print statements to print out potentially relevant variables, or use a debugger to step through the program, or use Python tutor. Debuggers integrate with an editor to visually inspect source code and internal state as a program is running. You can step through each line of source code one at a time, and you can set breakpoints. So breakpoints are a pretty key concept when it comes to debugging. Basically what you do is I've seen debuggers where you click a line of code, or you click in the margin of a line of code and it puts a stop sign in. And essentially what that means is the program will run until it hits that stop sign, at which point it will pause, and then you can inspect variables or step through the next set. You can step individually through the next set of statements. So it's kind of like the slide bar on Python tutor, but you kind of Python tutor's slide bar, Python tutor will only go up so far. You can only do so much with it. You can only do so big a program. So with breakpoints, you can do this on practically any sized program. And, it would be ridiculous to have a slide bar that went through, 150 million lines of code being executed. But, yeah, and the other thing is breakpoints. It's much easier to, it's much less resource intense to use breakpoints. Because you only save the data from when you're interested in it. So idle is a integrated development environment for Python. It's built into all Python installations, and you can run it by typing idle3. So let's try it out. Idle3. Idle3 not command. Well, that seems to be a lie then, doesn't it? My goodness. I could probably just install it, but, whatever. This is what it looks like anyway. So this is what it looks like on a Mac anyway. But so you've got your program, you've got your shell, like your Python shell, and then you've got a your debugging pane, which will tell you what all your local variables look like. The advantage of this over something like Python Tutor is the fact that you do have the Python shell available to you, so you can run like an individual function as many times as you want. Herp. Okay. Do print statements work with languages that are compiled since they execute all at once? Oh yeah. Yeah, print statements are universally applicable. The only languages that print statements don't work in are languages that are so low a level that you don't have a print. Like, you don't, like, if it's a lot of work to get to the point where you can print something, which is the case if you're programming in assembly, for example, then I don't recommend it. But with assembly, you can always do it inside of an emulator that functions very much like Python Tutor and tells you what the states of the registers are as you execute it. So, like, you can find, like, assembly-like environments that you can emulate stuff in. But, yeah. So let's talk about exceptions. Exceptions are actually really easy to understand. They're not that bad at all. But, so let's motivate exceptions then. Here's something to think about. Suppose you want to create a function that returns the maximum number in a list. What should your function return if you input an empty list? Right? Should it? I mean, I've kind of given away the answer. But if you don't know what an exception is, this will be helpful to you. So, what if we wanted this? Let's consider the case of 0. What if we had our function return 0 when it receives a blank or an empty list? Well, first of all, 0 wasn't in the list, so how can it be the maximum of the list, just logically speaking, even though 0 is used as a default for a lot of things. Number 2, like, what if the list is composed entirely of negative numbers? You know? 0, like, as a default value is actually greater than, you know, a lot of things that could also be, like, the, you know, possible maximum values. So you sort of have arbitrarily picked a number out of the middle of the range of the things that you could possibly have as valid results as an invalid result. And generally speaking, it's not a good idea if you're trying to set a value like an invalid result value. Don't make it something that's inside of the normal range of things that could be returned, like legitimately, because how do you tell the difference, right? So what if we returned infinity? I mean, if we had, like, we haven't even really talked about how to do infinity in Python. What about not a number? Possibly. What about false? Well, the problem with these guys is that we would have to check these results every time, right? Modularity. The problem with setting some special value that you would have to check each time is that it demodularizes your program, right? In Haskell, you'd return the empty list, good old pattern mashing. Yes. Yes, we should raise an exception, as we're going to see on the next slide. But, like, the problem with this guy, let's say that we return false, because, like, in this class, we've done it before, that, like, return false if the results are invalid. Well, it turns out that false is 0, first of all, which is kind of fun. I'll show you quickly. False equals 0. True. This is because the underlying bit representation of false is actually 0. well, okay. That didn't show what I wanted it to, so I'm going to ignore that that didn't work. Ha. But, basically, pretty much anything that you return here is going to be problematic in one way or another. What you really want is some way for the computer to say, this doesn't work. Right? So, and, like, if you have to check for specific results each time, basically you're putting more, like, you're putting requirements on the code that calls the function. And in general, everything that has to do with the function being called should be contained inside the function itself. So, so if we wanted to bin false, maybe bin false would work. Bin false. Yeah, there you go. Thank you. But you saw that equality worked, right? So if we set false to be the return value and we got 0 as an actual legitimate value, we would be in the same boat, right? We would be in the same problem where they're indistinguishable from each other. So if we were returning false from like a max and a min function, we'd have to insert all of this code to check to see if false was being returned, and even then, we wouldn't be checking. Like, this is still a flawed approach, because 0 would activate this. So, here's another question. What should happen when you pass a string or an integer, a string to integer conversion? Should we give 0? That's not what's actually entered. Should we give false? That's not an integer. So, for example, if I try to integer convert the word potato, or pototat, as it goes, what do we get? We get a value error. Invalid literal for int with base 10 potatat. Potato. Pototat. My God. So, this just answered our question of how Python prefers to deal with these types of problems. We raise an exception. Raise it out of the sea like the Colossus of Rhodes. Exceptions allow Python to deal with situations where it tries to execute statements that aren't well defined or violate some condition. So, the... Shut up. I don't care, pototat. I'm going to get through this lecture. Come hell or high water. So the verb that's associated with exceptions is raise. So the way that you create an exception, I should just keep this open. Raise value error. Ta-da! You can raise your own value errors. You can even raise errors with custom error messages. This is a custom error message. There you go. Name, oh, for God's sake. Exception. There we go. If you use the word exception, then you can actually produce exceptions with customized error messages, which is kind of cool. I'm not an English major, it's okay. Yeah, you know, I like to consider myself a reasonably fluent user of the English language, but... You guys are all talking about, like, whether it should return an ordered value and stuff like that. That's way beyond our level. Ignore what those guys are saying. So, in general, when an exception is raised, it either is handled, in which case you run an extra piece of code that is specifically designed to handle the exception, or it is unhandled, in which case the program crashes. So, it's now 10:20. We will polish off the rest of this next time in class. Well, okay. It's not above your level for, like, working in Haskell, because Haskell requires you to know that kind of stuff. Like, actually requires you to know that type of stuff. But for, like, some poor, like, life sciences or commerce student who's not taking 1JC3 and is just taking this course on Python, you do not have to worry about ordinals or ordered sets. You just have to know exceptions and exception handling. If you take 3MI3, though, we do need that kind of data, that kind of thinking. Don't take 3MI3 if you don't take the discrete math courses. Why am I a poor soul? We are all poor souls. You know I didn't mean anything by it. I don't think we got taught anything specific about overloading functions yet, though. Yes, yeah, we haven't done polymorphism in general, and we will get into polymorphism very slightly when we talk about classes. But polymorphism is kind of like a tricky subject in Python, anyways, because, you know, basically everything in Python is like very highly type polymorphic anyways because of duck typing. So it gets very complicated if you start digging into those details well beyond the level of a first year class. Like with 3MI3, we're not going to get to polymorphic types this semester. Like polymorphic types would be like grad level material even. Could I explain linked lists? Not when I've got another class to get to. Ask me tomorrow. I actually have slides on linked lists from other classes. I also have a comic about linked lists. Ask me about linked lists next time, okay? Yeah, just ask me tomorrow. But anyway, I've got another class to get to, so I'm going to sign off here. Keep it cozy, fancy meat computers.